All right, so today in this little video, like I said, it's gonna be a really small one. We're just gonna talk about Descartes' rule of signs. Now, this property, or this, it's really just a tool. It just gives us an idea of what our signs will look like for the zeros to our polynomial. So the polynomial that we're gonna be examining is 3x to the 6th plus x to the 5th plus x to the 3rd minus 2x minus 1. And how Descartes' rule of signs works is first, we're going to let p be a polynomial with real coefficients. That's exactly what we have above. And we're going to do both of these steps. So step one, the number of positive real zeros, so positive real zeros, is either equal to the number of variations in sign changes, okay? And it's always going to be either the number or an even whole number that's less than that. So like, for example, if I had 4 sign changes, okay, then that means I'm going to have 4 positive roots or 2 positive roots or 0 positive roots. So it always goes down by an even number, okay? Then we're going to look at the number of negative real zeros. Now, how do we do that? Well, that's going to be right here. So the number of negative real zeros of p of x is either equal to the number of variations in sign of p of negative x, or is less than that by an even whole number. So what we're going to have to do here is we're going to take our polynomial and then substitute negative x, simplify that, and then see the variations in sign change. All right? So like I said, I'm going to take this polynomial above. So this is going to be p of x equals 3x to the 6th plus x to the 5th plus x to the 3rd minus 2x minus 1. Now let me get rid of all this stuff here because I want to make sure that we can see everything nice and neat. So 1, we leave everything the exact same. All we're looking for is from term to term, we're looking for sign changes. So for example, from the first term to the second term, there's no sign change. 3 is positive, and this is positive 1, so no sign change. Now, if we go from x to the 5th to x to the 3rd, once again, it's positive, no sign change, okay? However, if we go from x to the 3rd to x to the 1st, notice this is a sign change, okay? And then finally, from -2 to -1, there is no sign change there. So right now we know we can have one positive root all right, we know that we can have one positive root, and that's basically it. Now what we're going to have to do is take p of negative x. So let's go ahead. We're going to put parentheses first. Then I'm going to make my substitution. So I'm just going to change my marker real quick. So substitute a negative x for each one of these. And then we're going to go ahead and simplify. So p of negative x is going to equal, well, a negative to the 6th power, regardless of what that number is always going to be positive. Now, a negative to the 5th power, remember the negative is inside the parentheses, and when the exponent is odd, it's going to be negative. So we get minus x to the 5th. Same thing happens with minus x to the 3rd. Then we're going to have plus 2x minus 1, okay? So now that we kind of have an idea of how this flows, we're just going to go ahead and we're going to look at the sign changes. So from x to the 6th to x to the 5th, you have a sign change. And then from negative x to the 3rd to positive 2x, you get a sign change. And then from 2x to 1, you get a sign change. So, and I'm going to leave this in red, p of negative x has 3 sign changes. All right, thus, p of x is going to have the following. So it has either 3 negative roots or zeros, or 1 negative 0. All right. And then finally, when you really take a step back and you look at it, we know we can have either 2 or 4 real zeros. And the reason for that is we know one is positive, and you're going to have this situation here, okay? So if one of them is positive, then you can have 3 that are negative. So 1 positive root, 3 negative roots. We're definitely going to have some sort of multiplicity here, okay? Or you're going to have 1 positive root and 1 negative root with a bunch of multiplicities, okay? But what's really nice about this is once you find that 1 positive root, because in both situations, we know we're going to have 1 positive root. So once you find that 1 positive root, you can get rid of all the other positive ones. And then you can focus strictly on the negative values. So like I said, this just kind of helps us. But what really helps us is the fact that we have like technology and calculators. I would just stick with the remainder theorem. But anyways, that's how Descartes' rule of signs really works. It is up to you if you want to use it or not. There's like one homework problem on it. I'm not going to put it on a test or anything like that. So I hope this video helped, and I will see you in the next one.